I came up on it, so I did.
Okay. Hopefully this is going to work. Where did the screen go? There we go. All right, we're going to start 6-1 tonight. And I was going to start with composite functions. So if you remember earlier this semester, we were doing functions. F of x is equal to 3x minus 5. And then I would say, okay, well then what is f of 5? And you would have to take the x out and put in the 5. You would say 3 times 5 minus 5, right? And then you'd just work that out. So that would be 10, right? Okay, well, we're going to be doing the same thing, composite functions, but now I'm going to be putting one function inside of another. Instead of just a number or a variable, we're going to be putting a whole function, okay? The notation for that is f of g. So f of x and g of x, f of g of x means that I'm going to put g of x inside of f of x. So instead of writing 2 times x, I'm going to write 2 empty parentheses with that 5, right? The only thing I left out of f of x is that x. So I'm going to replace that x with g of x. So I'm going to put x plus 8 in there. Okay, I just put g of x in for that x. So distribute your 2. So you've got 2x plus 16. Minus 5. And that's going to give you 2x plus 11. Right? We left out this x. We put in x plus 8 from my g of x. And then we just distribute and simplify it down. Okay, now order counts because this is f of g. You see how g is on the inside? G is the one I put inside. If I said, why do you have such a problem? If I said g of f, now f is on the inside, so I'm going to be putting the 2x minus 5 into the x plus 8, right? So the x, I'm going to leave out, and I'm going to put in 2x minus 5. Now there's nothing to distribute, so I'm just going to have 2x minus 5 plus 8 gives me 2x plus 3, right? Just insert 1. That's what this composite is telling me to do. Put 1 inside of the other, right? Not too bad,
I start out.
You don't trust me?
I trust you 100%.
It's the math.
Okay. All right, now this one's a little harder because I have an x squared. Let's see what you can do with f of g. Well, okay. So that means I've got to put g of x into f of x, right?
question.
Mhm.
When you put the two, when you put it inside the 3 plus the 2,
Mhm.
would you do the time first, like a 2
Mhm.
times 3? Okay.
Distribute, yep.
You know what I'm saying? So you're gonna do it after.
Yep. So here's my 3x plus 2. I dropped the x, and I'm going to replace it with 2x squared minus 1. Then I got to distribute that 3. So I have 6x squared minus 3. Bring down my plus 2. 6x squared minus 1. Yes? Now your red flag on this one, honestly, where people miss this the most is they forget that plus 2. They forget whatever that end number is.
I put plus one, I ain't lying.
I got +5, but I thought that the equal sign was a negative.
Oh, okay. So you thought that was a negative 3?
Yeah.
Okay,
So why would it be minus one instead of plus one? I put plus one.
because I got 3 negatives and 2 positives. So I got more negatives, right? I'm down by 3, I score 2,
On the negative side, going down.
right? All right, I got a little bit more work, because this time I'm gonna say 2, but that parentheses, that x is being squared, and I'm gonna replace x, not x squared, so the square is gonna stay in there. So I have to put in 3x plus 2. So now I'm gonna have to FOIL that out, then distribute that 2 and simplify.
Oh.
Right? Because I'm replacing this x, right? And this x is being squared. So whatever I'm replacing that x with, I've still got to square it. First outside, inside last. Nine x squared, 6x, 6x and 4. So 2 times 9x squared plus 12x plus 4. Distributing my 2, I have 18x squared plus 24x plus 8. And then I got to simplify with that minus 1. So I've got 18x squared plus 24x plus 7. Kinda yes? No. Okay. Let's try another one. So what if f of x is 3x minus 2, and g of x is x squared plus 8. If I'm going to do f of g, that means I'm going to put the g into the x, right? So I'm going to say 3. I'm dropping that x minus 2. So this one's the easier one. How do we do? Did we get that 22 on the end? So maybe it help if we just think about what we're going to do with x to start with right here. What's going to happen to x? I've got to multiply it by 3, and then I got to subtract 2, right? Well, now my x is going to be x squared plus 8. So what do I have to do to x squared plus 8? I got to multiply it by 3. That's where I'm distributing here. 3 times x squared gives me the 3x squared. And then 3 times 8 gives me the 24. So I got to multiply it times 3, and then I got to subtract that 2. So 24 minus 2 gives me 22. All right, what am I going to do to x on this side? G of x. What am I going to do to x? What two things have I got going on? I got to square it, right? Got to multiply it by itself. And then I got to add 8. So if I'm doing f of if I'm doing f of or g of f, that means that this x, just this x right here, is going to become 3x minus 2. So what do I have to do to 3x minus 2? And then add 8, right? So I'm going to have 3x minus 2 squared plus 8. 3x minus 2 times 3x minus 2. Can you guys see that blue okay? Mm-hmm. And then the plus 8. So here I got a FOIL. First, outside, inside, last. 9x squared minus 6x minus 6x plus 4 plus 8. 9x squared minus 12x plus 12. Yes? Uh-oh, what'd I do?
I said, I got it.
All right. The next is about the domain. I know, we love this. Remember, when it comes to the domain, of a function, I have those 3 rules, those 3 things I've got to guide by. If I have x in the denominator, remember I cannot have a 0 in the denominator, right? That's undefined. It's not allowed. If you punch in any number and try to divide it by 0, your calculator is going to give you an error. Then the other domain was if I have the square root of x. Square root cannot be what kind of a number? It can be negative, right? So x has to be greater than or equal to 0. Then if I have a combination, then it's just got to be greater than 0. Okay? So when it comes to a composite function, let's say I have f of x is equal to x squared plus 4. What's the domain this Monday night? This was a test question. What's the domain of any quadratic? All real. So the domain for this is all real. What if I have f of x is equal to 2x minus 5? What's the domain of any linear equation? Any equation that just a straight, what's the domain of those?
Whatever crosses the y.
No, the domain, the x.
Oh.
That's going to be another all real, right? So, whoops, I shouldn't have wrote f of x. That should be g of x. So if I ask you for the domain of a composite function, f of g or g of f, it doesn't matter. If they're both all real, then the domain will be all real. Okay? If they're both all real, then the domain's going to be all real. What if they're not both all real, though? So I'm going to replace, I'm going to say f of x is 3 over x minus 5. And I'm going to say g of x is 2x plus 1. For f of g of x, I'm going to look to the inside function first. 2x plus 1. What kind of a graph is that? That's that linear one, right? And the domain is all real. So far I'm doing good. But is my domain going to be all real here? Right, so I can't have that. What would make a 0 in my denominator? What do I have to do?
Multiply by zero.
No.
But
X minus 5
minus 4,
equals 0. Right? If I got to find out what would make this a 0, then I'm going to set it equal to 0. Does that make sense? So I'm going to add 5. So X equals 5. So if a 5 going in here is going to give me a 0, then for my domain, X cannot equal 5. Right? My domain, I can have every X in the world to use this graph, but it cannot be a 5. Because if it's a 5, then 5 minus 5 gives me 0. And I can't have that, right? All right, so here's the thing. Even though this is all real, if I'm doing f of g, then this here, this 2x minus 1, has to go in where that is, right? So if 2x minus 1 is going in for this x, what number cannot be right here? 5. So that means that 2x plus 1
must be more than 5.
on the right track has to be more than 5. Could be less than 5. It just cannot be 5, right? 2x minus 1 cannot be a 5 because I can't have a 5 right there. Does that make sense? So I got to find out what would. I got to find out what number would turn that into a 5. So just like I had to set that equal to 0, I got to set it equal to 5. So minus the 1, 2x equals 4, divide by that 2, and x equals 2. So my domain for f of g of x is going to be the set of x such that x does not equal 2.
It's not gonna equal 2.
Come on. Come on. All right. Gonna try it again?
Take a picture of something.
Okay. Well, again, we are recording. So the video of everything we do will be in Google Classroom. You might want to write something down maybe. Okay. All right. So let's try. We'll say f of x is equal to what kind of graph am I going to get from x plus 4? What is that? That's linear. That's my just straight line, right? So on a linear, my domain is all real. Do I have all real over here? Rational equation, I can't have that 0 down here, right? So what do I do?
Set it as 0.
Subtracting that 1. And dividing by that 2. So x cannot equal a negative 1/2. So this x right here cannot be a negative 1/2. But that's where this x plus 4 is going, right? Because this has to go inside of this one. So I need to know x plus 4 equals negative 1/2. Subtract that 4, and x equals a negative 4.5. Right? What's a half and a 4? 4.5. That's the hardest thing we got tonight.
So we're not doing these, like, when we're talking about domain, we're not doing like we were doing the first part.
Yeah, well, that's what I'm doing. That's why I need to be able to, because like what I'm doing is 5, 2, x plus 4 plus 1. I'm still taking out this x and putting in g of x because it's f of g, right? I'm just trying to do a little bit of a shortcut by saying, you know, all I really need to know is what would give me a 0 here. So instead of having to figure all of this out, which I could do, I could say this is 5 over 2x plus 8 plus 1, which would be 2x plus 9. And then what would happen if I set that equal to 0? If 2x plus 9 equals 0, and divide by the 2, how many times will 2 go into a 9? With 1 left over, right? So I'm still going to get that negative 4.5. I'm just trying to say, if I just focus on this one right here, then I don't have to do all that.
So we do that every time.
Put it in there. Make sure, find out what would make a 0 here. Anything that would make a 0 here, I can't have, right? So 1/2 would make this a 0. 2 times a half would give me 1, or negative 1 plus 1 would give me a 0. I can't have this right here. So that means this guy, this x plus 4, cannot equal a negative 1/2. So I got to find out what x would do. And that's a negative 4.5. Yes?
So do you win?
Are you so serious tonight?
Is the negative
Tired.
4.5 the answer?
Yes.
Okay, I thought there was like another step after that. Okay.
Domain is such that x cannot equal a negative 4.1/2. 1. You go whichever way is, if this way here, if going ahead and creating the composite function is easier, then that's the way you should do it. But just because I think it's easier doesn't mean it's easier for you, because we got different brains, you know?
That's my work for me. I developed it.
All right. So we gotta make it harder.
You don't have to.
I know, but what if it shows up on your final?
I'll just pray.
Just pray.
Just pray. It's a 1 in 4 chance, you know.
All right, work this one with me. Neither one of these are going to be all real, right? Because they're both rational, right? They both have an x in the denominator. So I'm going to start by just, what would my restriction be on g of x? If I have x minus 1 in the denominator, what number cannot be x? Right? X cannot equal a 1, because 1 minus 1 would give me that 0. Right? So x can't be 1. Well, that's going to be part of my answer right there. The domain is going to be the set of x such that x cannot equal a 1. But now, if I'm doing f of g, this whole thing has got to go in for that x, right? Well, what can this x not be? -2, right? So I've got to say 4 over x minus 1 equals -2. This can't be a -2 here, right? So I've got to say, all right, what would make this a -2? Whatever can't be here, I got to take the inside function and put it equal to that. How do I solve these rational equations? You guys must have been talking because somebody told me earlier by praying. So we got praying in the air. Multiply both sides by that denominator. Whatever's in the denominator, we're going to multiply because it cancels off of here. Right? Now I no longer have a rational. 4 distribute -2x plus 2. Now it's just a two-step. -2x plus 2 equals 4. Just a two-step equation. Subtract that 2. -2x equals 2. Divide by -2. And x equals -1. So I got to put that up in my answer set. Does not equal 1 and does not equal -1. When I go to graph the composite function of f of g, there is going to be a break in my graph at 1 and there's going to be a break in my graph at -1, or there won't be any line. All right, let's move on to something easy. You want to look, keywords, domain of composite function. If you want to look for some stuff on the internet to get some help, that was domain of composite functions. All right, we're going to move into 6.2. Now, if I have let's say I have the relation 2, -8, 3, 6, 1 or -1, 5, and -4, 9. Do I have a function? Is this a function?
Yeah,
How do you know?
because no x or y is the same.
Okay, so as long as, so the question of function, I got to look at x, right? None of them can repeat. None of them can be the same. If none of them are the same, then yes, it's a function, right? But I'm not going to ask you. I'm going to tell you it is a function. I'm going to say this function, is it 1 to 1? I'm going to give you the fact that yes, it is a function because all of the x's are the same. But now you got to tell me, is it a 1-to-1 function? Okay? And that's all you're going to have to do is check out those y's. And it's going to be the same thing. Are all the y's different? Then it's going to be yes. If all the y's are different, then it is, yes, it's a one-to-one function. I've already given you the fact that it's a function. But I'm asking you, is it one-to-one? Okay? Now, if I had a parabola, what was that? If I was looking at, I wasn't looking at a set of coordinates, but I was looking at a graph and I was asking functions, yes or no. What did we do to find out? What did we have to find out if this was a graph was a,
Straight line test.
what was it, what kind of a line is going?
Vertical.
Vertical line test. Remember when we take the line across our graph? If I did not touch this graph in more than one place at the same time, that meant all of my x's were different and I had a yes, right? The parabola, the quadratic, that was a function. Now, is it a one-to-one function? If it's a one-to-one function, it's not only going to have to pass the vertical line test, but it's also going to have to pass the horizontal line test. Would this pass a horizontal line test? No. It would be touching anywhere, an infinite number of places. It's going to fail. So it's a function, but it's not one-to-one, right? What does the cubed function look like? Remember when I have x to the third? Yeah, like that long, stretched out snake. Right? Now, I know this looks like it's just going straight up, but it's getting wider. Just very, very slowly, it's getting wider. This will pass my vertical line test. It's a function. Will it pass my horizontal line test? So it is not only a function, it's also one-to-one. Okay? We're in 6-2. This is part of 6-2, not 6-1. Oh, there it is. All right. Inverse functions. Well, again, this is the easy stuff. This is the stuff that we want to make sure we have down because I don't have any calculating to do. If I give you a set of coordinates and I say, give me the inverse function, all you're going to do is swap your x and y. That's it. If I have 2, -5, my inverse is going to be -5. Notice I didn't change anybody's signs, right? Just swap their place. 3, 7 is going to be, and -4, 1 is going to be, right? So when I'm asking for an inverse function on a set of coordinates, all you're doing is swapping. What about if I ask for an inverse function on a graph? So I have -4, -3, -2, 2, and 2, 5. And I say, graph me the inverse function.
Is it what are you supposed to do?
Nope. Just swap your x's and y's. So instead of plotting -4, -3, I'm going to plot, right? Instead of plotting -2, 2, I'm going to plot, and instead of plotting 2, 5, I'm going to plot 5, 2. Right? Yes? Okay. So serious tonight. All right. Inverse is swap. Yes? The only thing we've talked about tonight that was that domain business. Yes?
Yes.
Okay. So what if I need the inverse of an equation? Trust me, it's still easy. I'm still going to swap. What's f of x? What's f of x?
Oh.
What's my y, right? Equals 2x minus 5. Now, what did I say we're going to do whenever we're doing that? Swap them. So my first is going to be swap x and y. So I'm going to say x equals 2y minus 5. Okay? Now, I need to get that y alone. So it's a two-step equation. If I need to solve for this y, 5 is the constant, 2 is the coefficient. What am I going to do first to get this y by itself? Add the 5, right? Because I want to cancel out this 5. So I'm going to add the 5 to both sides. All right, I still have one more. Whoa, I'm sorry. X plus 5, right? All right, now it's 2 times y. And I need that y alone. So how can I get rid of that 2? If they're multiplying, opposite of multiplying, divide 2. That's gone. So my inverse, and that's that word right there, that negative gives me the word inverse. The inverse function of this f of x is going to be x plus 5 divided by 2. We're still just going to swap that x and y, and then we're going to solve for y. Okay? Try it at 4x plus 2 for me. Swap x and y and solve for y. You missed a test Monday. Can you be here Monday at 4? Oh. 4x plus 2. Swap them. X equals, right, getting this y alone. Constant always goes first. Minus 2. 4 times y. Divide by 4. So the inverse function of f of x is equal to x minus 2 divided by 4. All right, we got to go back to those composite functions, what we started tonight with, right? Those weren't too bad. What if I give you 2 and I say, are they inverse function? So here is my f of x. Here is my g of x. And I'm not going to tell you to find me the inverse function. I'm going to say, are they inverse functions? And you're going to have to say yes or no. Okay, so how do you find out? you need to do f of g of x. See if it simplifies to x, and g of f of x, and see if it simplifies to x. So if I'm doing f of g, and I got to get both. If I'm doing f of g, that means I have 4 minus 8, the composite function. What I dropped this x, what needs to go in there? Okay. F of g, I'm putting g inside of f. All right, what happens if I multiply times 4 and divide by 4? Cancel, so that's just an x, right? 4 times 2 minus 8. So that's just equal to x, right? So f of g of x simplified to x. Now see if g of f of x is going to simplify down to x. Find me g of f. Can this reduce like any fraction? There's a 4 in each one of these, isn't there? So 4 divided by 4 is 1. 4 divided by 4 is 1. 8 divided by 4 is... So I've got x minus 2 plus 2, and that equals x. So are these inverse functions? Yes. What happens if I end up with like a 5x down here? Then my answer is just no, right? If it doesn't simplify to x, both of them have to. I can't do just one and answer. I've got to do both f of g and g of f. And if I get an x on both, then it's a yes. If I get anything else, then it's a no. Okay? Yes? Let's do one more. There's my f of x. There's my g of x. Better?
Yeah.
We'll see you Monday.
All right. That's okay.
Thank you.
Yeah.
F of G. What's going in the parentheses? 1/2 x minus 3. Distribute that 2. 2 times a half is minus 2 times 3 plus 6. So that takes me down to just G of F. 1/2 minus 3. So since F is on the inside, I got to put F of X inside of G of X. 2x plus 6. Distribute that half. Half of 2 is 1x plus 3 minus 3. Those are gone, and I get left with x. So again, my answer is yes, right? Anything besides just x, then my answer is just no. Doesn't mean I've done it wrong. Just means my answer is no instead of yes. Okay? Yes? All right. Monday we're going to start talking about logarithms. But it's April. Yeah, right? I mean, I think your final is at the last day of April, I think. I don't even think you guys go in May. You go in May. You guys will take your final, anything after 4 o'clock, any classes that start after 4 o'clock, take their finals before dead day. So you guys will be done with the end of this month. All right, guys, we'll see you Monday.
Sheesh.